So let's have a look at the review for right triangles, Unit 8, and I'll dive right in. The first one says we want to find x right here. Now, if you remember, a 5, 12, 13 is a triple. It's a Pythagorean triple, and maybe you can just remember right off the bat it's 5, 12, 13. But if you cannot, 5 squared plus 12 squared equals x squared. So I'll grab the calculator and go 5 squared plus 12 squared. That equals x squared. That's 169. So when I take the square root of 169, I get 13. X is 13, just like the Pythagorean triples said. Now, in the next one, we also have a Pythagorean triples, but it's 6x and 10. This is actually a triple, and it's 6, 8, 10. But if you don't remember that, it's 6 squared plus x squared equals 10 squared. Remember, the hypotenuse is this part over here by itself. So that's 36 plus x squared equals 100. So then I've got 100 minus 36 gives me 64, and the square root of 64, of course, is 8. This side is 8. Now, on the next one, there is a quick way to do it if you remember the 45, 45, 90 idea, because it's an isosceles triangle. But perhaps you don't remember that, and so what you've got, I'll switch colors so you can see this, is x squared plus x squared equals 6 square root of 2 squared. Now, I saw a number of students today working it, and they didn't square this part over here. You've got to square it. If you're good at squaring it, great. If you're not, grab a calculator. 6 square root of 2 is that squared. Oh, look, it's 72. That's nice. So I've got 2x squareds over here equals 72. Divide both sides by 2, and I get x squared is 36. So x is just going to be 6. Move this a little closer here. All right, so this job right here, again, Pythagorean Theorem. Maybe you remember it's a triple, maybe you don't. If you don't, it's 7 squared plus 24 squared equals x squared. So on the calculator, it's 7 squared plus 24 squared, and then take the square root of that number right there is 25. So x equals 25. It's a 7, 24, 25 right triangle. Number 5 says the rectangle has a diagonal of 2 centimeters and a length of the square root of 3 centimeters. Find the width. Draw a picture, please. Please draw a picture. It's got a diagonal of 2, a length of the square root of 3. Perhaps you can recognize this triangle, but if you cannot, this is what we're looking for. We know it's right because it's a rectangle. So x squared plus square root of 3 squared equals 2 squared. So square root of 3 squared, that's 3. So x squared equals 1 when I subtract 3 from each side, and x has to be 1. Finally, number 6, find the length of the diagonal of a square with a perimeter 16. If the perimeter is 16, perimeter, the distance around, distance, meter, peri, around. So each side has to be 4 because they're all the same. And it says we want to find the diagonal. Again, maybe you recognize this is a 45, 45, 90. And if you do, you can tell this is going to be 4 square root of 2. If you cannot tell that, work it out as a Pythagorean theorem problem. Now in this next section, we want to see if we can make a triangle, and if we can make a triangle, is it acute, obtuse, or right? So the first thing is I want to know, do the two small sides add up to be more than the third side? So is 8 plus 8 square root of 3, is that going to be more than 16? I'll put a little question mark there. I don't know. Let's grab a calculator and see. 8 plus 8 root 3. Oh yeah, that's 21.9. 21.9, that's bigger than 16, so the answer is yes. Since it's a triangle, I can now talk about what type of triangle it is. And so I'm going to take 16 squared, take the big side squared, and I want to compare it to 8 squared plus 8 root 3 squared. So this is 256. This is 64, and you say, Coach, I don't know 8 root 3 squared. Well, that's fine. Grab you a calculator. 8 root 3 squared, 192. All right, so plus 192. What do we have there? 64 and 192? That's 256. Look at that. Equal, so it is a right triangle. All right, let's look at another one of these. So when I look at the next one, can I make a triangle? Is 11 plus 11 bigger than 15? Yes. So it is a triangle. That's the first step. Now take 15 squared and compare that to 11 squared plus 11 squared. So that's 225 compared to 121 plus 121. So that's 225 compared to 242. Well, look, that's not big enough. It's not big enough, so it squeezed that angle down, making an acute angle. And then this next one is 8 plus 14 bigger than 22. Oh, no. So it is not a triangle. If it's not a triangle, don't waste time telling me what kind of triangle it is, because it's not a triangle. Now this next set of problems I'm going to do a couple of different ways. I'll do them as though you know the 45, 45, 90 and 30, 60, 90 ideas, and then we'll also work some using the Tic Tac Toe method I've done in a different video. So this one is a 45, 45, 90. So these sides are the same. So if FB is 6, then BI is also 6. And this side over here is going to be 6 square root of 2. Likewise, on number 11, we've got an isosceles triangle because that's 45. So if this is 10 root 2, each of these guys have to be 10. And that's something that you may have memorized. I'll use a different method here in a minute. All right, we've got a 45, 45, 90. This might be a little tougher for you. So let's use the Tic Tac Toe method. So the Tic Tac Toe method says if I've got 45, 45, 90, that's in the 1, 1 square root of 2 ratio. But in my triangle, I've got this side, which we'll call X. I've got this side across from this 45, we'll call Y. And then 12 is across from the 90, so it goes here. Note where these things are here, it's because they're across from those particular angles. So first things first, let's look at these two things. So I'm going to look at x over 1 equals 12 over square root of 2. Now x over 1 is the same thing as x. But I need to rationalize this guy. So that's going to be 12 square root of 2. That's going to be 2. Square root of 2 times square root of 2 is 2. And then that reduces down to 6 square root of 2. Now I could repeat this process by using this and this. But I know it's 45, 45, 90. So if this side is 6 square root of 2, so is this side. 6 square root of 2 is my answer. Now what if it's a 30, 60, 90? Maybe you remember this. Maybe you know this side is the 2 side. This is 30 degrees, so this is half of that. And this is that number times the square root of 3. So DE is 6.5 root 3, and EA is 6.5. It's fantastic. If you don't remember that, I'll use this Tic Tac Toe method in just a second. All right. What about 14? So let's use the Tic Tac Toe method right here. So in the Tic Tac Toe method here, I've got 30, 60, 90, and that's 1, square root of 3, 2. You have to remember that. In this particular triangle, that has to be 90 because they have to add up to 180. Across from the 30 is 3. Across from the 60, let's call that x. And across from the 90, let's call that y. So, when I work this problem out, give me some more room to work. Here's what I've got, 3x, y. Okay, so I'm going to first use this. So I've got 3 over 1 and x over the square root of 3. 3 over 1 and x over the square root of 3. Cross multiply. There we go. Bada bing, bada boom. 3 square root of 3 is x. X was this side down here, ed. So this is going to be 3 square root of 3. Now, to do the other part, I'll use this side. So that gives me x over the square root. Oh, no, I don't want to do that. Well, I could do that. That's 3 square root of 3 because I just found it. Sorry, let's use this one. 3 over 1. That way I only have one letter at a time. 3 over 1 and y over 2. Cross multiply. Y is 6. That side, FE, is 6. All right, so let's go down to 15. 15, this side is opposite the 60. I'll use the Tic Tac Toe method again. So the Tic Tac Toe method. 30, 60, 90, 1, square root of 3, 2. That part stays intact because it's a 30, 60, 90 triangle. Now across from the 60 is a 6, so that goes right there. This angle must be 30, so let's call that x. And this hypotenuse is across from the 90. We'll call it y. Okay, so there's my tic-tac-toe. So when I make my equations, I'm going to use x over 1 equals 6 over the square root of 3. I like using this one because I know the numbers in most spots. And then I'll use it again. I'll go 6 over the square root of 3 equals this one, y over 2. So when I solve this one, I get, oh look, the x is already done, so it's already over 1, so I have to rationalize it. So that's 6 square root of 3 over square root of 3 times square root of 3 is 3, and then that cancels. 6 divided by 3 is 2 square root of 3. So x is 2 square root of 3. X we said was hi. This is 2 square root 3. Now on this side over here, I cross multiply here. I get the square root of 3y is 12. I'm going to divide by the square root of 3. Y equals 12 over the square root of 3. Let's rationalize it by multiplying by the square root of 3 over square root of 3, which is 12 square root of 3 divided by 3, which reduces to 4 square root 3. Woo! So that dude is 4 square root 3. Now I do think it's easier if you understand the formulas and how they all work, but if you don't, this method will get you there. It just may take you a couple more steps. All right, look at this crazy triangle. We got all sorts of stuff going on here. A couple of triangles crammed up next to each other. Well, let's see if we can remember this. If this is across from the 60, the part across from the 30 is just going to be this divided by the square root of 3. So in this case, it's just 9, which is WS. So WS is 9, or SW, same thing. And then this side across here is going to be double that. It's across from the 90, so this is going to be 18. Now this other triangle is a 45, 45, 90. This blue job here. So this is 18. To get these sides, it's 18 over the square root of 2, which has to be rationalized. Which reduces. So these two sides are the same, and they are 9 square root of 2. I'm doing this a couple of different ways. If you like the Tic Tac Toe method, you can certainly do that on this problem. It's a little quicker if you understand the other way. The Tic Tac Toe method certainly gets it right. Okay, so now I want to write ratios for these things right here. And a ratio is just one number divided by another number. So I've got to remember for this section, SOHCAHTOA. And the first one says the sine of L. Well, there's L. So with regard to L, this is opposite, this is adjacent, and this is the hypotenuse. So the sine of L is opposite over hypotenuse. That's 12 over 15. It says to do it in simplest form, so I can divide both of those by 3, and I get 4/5. All right, the cosine of L, same angle, but it's adjacent over hypotenuse. Adjacent over hypotenuse. So this is 9 over 15, which reduces to 3/5. And then the tangent is opposite over adjacent. So it's 12 over 9. And that reduces to 4/3. Now, if instead I want to look at things from this perspective down here, this side is still the hypotenuse, but now this side is the opposite, and this side is the adjacent. So you got to be careful with that. And so the sine of n, the sine is opposite over hypotenuse. So the opposite is 9 over 15, which reduces to 3/5. Some of you will note that the sine of n and the cosine of L are equivalent. The cosine of n is adjacent over hypotenuse, so adjacent 12 over 15, which is 4/5. And finally, the tangent of n is opposite over adjacent. And it might be confusing to you with all these words written here. I'm trying to color code it so you can see, but if you'll just pay attention, you might not even have to label it. Just pay attention to opposite over adjacent. That's 9/12, which is 3/4. All right, so let's slide into this next part here with a question like 23, 24, 25, and 26, where I've got triangles, I've got an angle, I've got to find the other stuff. First of all, if you know one angle, finding the other angle should be pretty straightforward. If this is 63, this has to be 27, because all three of them have to add up to 180. If this is a 90-degree angle, that means these two have to add up to 180. So if this is 61, what is this? Well, that's going to be 29. All right, now the next part, to find these guys here, I'm going to have to use some other function. And so it says to find AB, so I want to find this right here. I want to find that right there. And I would refer you to the original given information, just in case you made a mistake here. So relative to 63, I've got the adjacent side and the hypotenuse. The adjacent side and the hypotenuse. That's these two guys. So it's the cosine. So the cosine of 63 is the adjacent side over the hypotenuse. So you might have to fiddle with this a little bit. I'm going to multiply both sides by x and divide both sides by the cosine of 63 to get that x is 12 divided by the cosine of 63. Work on that algebra if that's not your strength to make sure you can get that right. So 12 divided by the cosine of 63 is 26.4. It does say up here to do it to the nearest degree if I've got that, or the nearest thousandth if I have a side. So this is going to be 26.432. Now at this point, I could either use another trig function to find this other side, or I could use the Pythagorean theorem. I kind of like trig, so that's what I'm going to do. To find this side down here, let's call it y. The sine of 63 equals, well, you could do a bunch of ways. I'm going to do the sine of 63 is y opposite over hypotenuse that we just found, 26.432. So multiply both sides by 26.432. That number is actually still in my calculator, so I just need to multiply that by the sine of 63, and I get 23.551. That's this one. All right, let's look at number 24. So on number 24, we've got this right here. We already found that 29, and I want to find EF. That's this side over here. So relative to 61, this is adjacent and hypotenuse. Adjacent and hypotenuse, that's the cosine. The cosine of 61 is adjacent over hypotenuse. And maybe you can see that's going to be 100 cosine 61. So on my calculator, 100 cosine 61, 48.481. That's EF, that's this one, 48.481. And this is a good time to remind you, if you're not getting these answers, it's possible that if you hit mode, your calculator's in radians instead of degrees. Be careful with that, it needs to be in degrees. All right, so to find DF, I'm still going to go off of 61 this time, but now I've got opposite and hypotenuse. That's the sine, the opposite and hypotenuse. So now I've got the sine of 61 is opposite and hypotenuse, or 100 sine of 61 equals y. So 100 sine of 61, that's the other one, 87.462. 87.462. Now, if you say, Coach, I'm not very good at these, I'm not confident, I don't think I got them right. Okay, check it out. 48.481 is this side, and 87.462 is this side, and this is 100. Now, I think it's a right triangle. It tells me that right there. So what should happen is if I take 48.481 and I square it, and I add 87.462 and I square it, gives me that. That ought to equal this other side squared. Let's take the square root of that. Remember, we rounded to the nearest thousandth? That's why over here it's out of whack. Look at that. 100, 100. Just what it's supposed to be, because we did it right. All right, I'm going to finish up with these two and leave part 4. There's further word problems for you guys, but here's the last couple. These, we want to find angles. When we want to find angles, we need to use the inverse function. So let's put a little theta in here. So I want to find theta. And relative to this angle, what are 7 and 11? Well, it's a place you get Slurpees. It's the opposite over the adjacent. That's the tangent. So the tangent of theta is opposite over adjacent. So what I want to do then is the inverse tangent of 711 to make that work. So I'm going to go second tangent. That gives me the inverse of 711 rounded to the nearest degree. That's 32. Now the simplest way to do that is if this is 32, then this angle up here must be 90 minus 32, or 58, because remember they have to add up to 180. So how would I find RS? Well, you could use your trig functions, but you can also use the Pythagorean theorem, where I know 11 squared plus 7 squared equals x squared. So 11 squared plus 7 squared is that, And the square root of 170 is that. It said round it to the nearest thousandth, 13.038. 13.038. And finally, this last one right here. So let's start with this is theta. So adjacent and hypotenuse, that's cosine. So the cosine of theta is adjacent over hypotenuse. So theta is the inverse cosine of 15 over 17. The inverse cosine of 15 over 17. 28.072. Rounding that off, that's 28. I should put degrees on here. That's a good habit. Which means the other angle is 90 minus that. So this is 62 degrees. Now to find this one, it's this squared minus this squared equals that squared. Again, the Pythagorean Theorem. 17 squared minus 15 squared equals 64. The square root of 64, of course, is 8. And this, perhaps you recall, is a Pythagorean triple. So there is the first good chunk of your review sheet, leaving some of those other problems to you guys to work on. And, of course, the answers are on Schoology. Good luck.